Okay, so this says lesson 1, but we may get more done than this today anyway. So I'll just work on it until we basically run out of time, and then we'll continue into the next period. Because this file we can't do in 1 day, it's just too much. Okay, so the basic ideas for quadratics. Now you've seen these before already when we did polynomials. Okay, your first definition is an expression, quadratic expression, and that will be written like this. So it will be x squared. You must have an x squared somewhere, plus a lower degree term. So x squared plus 4x, or it could be 2x squared minus 3. That's another one. We don't have to have the x term, okay? You can just have minus 6x squared. That's another expression. Okay, you don't have to have x or a constant, or you could have all three, like minus 3x squared plus 4x minus 2, something like that. Okay, let's just check, got everyone. Okay, so these are all expressions. What you notice that we don't have an equal sign. So if you had something like the first one, x squared plus 4x, there's not much you can do with this. We can see that we can factorize it, and that's basically it. So x plus 4. So we can factorize expressions like this, but there's not anything else we can do with this. All right. And some expressions, obviously, you can't factorize, like the first one. Not easy to factorize that. If we do factorize that, we'll end up with fractions. So we don't really want to do that. So these are expressions. You'll notice there's no equal sign. But if you want to turn this into an equation, we put it equals something. Okay. It doesn't have to be equals 0. It could be equal any number. So anything that's a quadratic could be x squared equals 4. You could have something like that. Now, these may or may not have solutions. Okay. So this one will have a solution, but x squared equals minus 4. This won't have a real number solution. So this has a solution, but this one has no real solution, which you'll see later when we come to solving these. So these are equations in one variable, the variable being x, okay, in this case. So this is your variable here. And it could be written in h. So if you had something like, so h squared plus 2h minus 3 equals 6. Okay, this variable would be h then. Okay, that's your variable h. And maybe we can solve that as well, or maybe not. It may have a solution, it may not. So these have one variable, x, and we can solve them. Generally, we are able to try to solve them if you have an equal sign. But some student I've seen in the past, they get something like this, and then they put equals 0 on it or some number. I don't know why they do that, because it's not there. So it can sit by itself, and we just call it an expression. Okay, so don't put equals 0 or equal a number when it's not there. We don't do that. But if it has an equal 0, this means we try to solve the equation. We are trying to solve these for x. And maybe there's 2 values. We tried to find x. But equation that have 2 variables like this. And these are also called functions, which I use this word a lot in grade 10, function. Okay, and you're going to see more on that later. So don't worry about this terminology, but I may use it sometimes. I might call quadratic function, but it's the same thing as what's written here. Okay, so these have 2 variables, y and x. Okay, you could have it written as h equal 3t squared plus 2t minus 1. Okay, so this is also another quadratic equation in two variables. Now, if we wrote that as a function, which you'll see next year, we could write this one here as y. Oh, sorry. I could write y, but let's write it as fx equal x squared plus 4x. So when you see something written with f or even g, it doesn't really matter. Could be named something else. So these are written as a function. So these are your functions here, but it's exactly the same as what is written here. The only benefit to this is if you want to find f1, for example. So when we write in function form, this is telling you to write this one into your function here. So you'd write 1 squared plus 4 times 1, which is 5. So what that means is that when x is 1, y equals 5. So what I could have also written is y equals this, because y is the same as fx, okay? So don't get too confused by this now, because this is notation we use later. So that means when x equals 1, y will be 5. And we can use that idea to draw the graph. Okay, I'll get this out the way because not really important for this time, functions. Just be aware of that word when I use it. And I'm talking about these kinds of graphs here. That's your notation I wrote there, okay? So normally when you've got something like this, we're graphing them. We're drawing graphs, okay? When you see it written as two variables. And we're going to do graphing in chapter 5 a lot, okay? So don't worry about graphing today. The main thing we're going to be looking at is your solving the equations, okay? So that's just some basic information at the start. Okay, so take a look here. The key to solving quadratic equations and higher equations like cubic equations that you did already in polynomials often requires you to factorize first. To do this, we use the Null Factor Law. Okay, so what the Null Factor Law is saying that is if you have two numbers, A and B, and when you multiply them, you get 0. That either means that A is 0 or B is 0. So for example, if you had 3 times what equals 0, you can see that this must be 0, mustn't it? It can't be any other number. So this number in here has to be 0 to get a 0 answer. Okay. And the same as if the number was in the front. 0 times minus 6 is 0. What number goes here? You can see it must be 0, because any other number you won't get 0, will you? Because like minus 2 minus 6 will be 12. Okay, that's not 0. And so on. Okay, so the number that goes in this box must be 0. So with a simple example here, let's see how we use it. So the first thing we do is take our simple quadratic and we factorize it. So when you factorize it, you'll get x bracket x plus 4. I know you know how to do this because we did this already in polynomials. So factorize out your x, and then you will get x bracket x plus 4 equals 0. So the Null Factor Law states that either this is 0 or this is 0. This is what's written here. So let's write that again. I'll show you this here. So x plus 4 equals 0. So to get a 0 answer here, either x is 0. So if x is 0, we'll get 0 times 0 plus 4, won't we? Which will get 0. Or this must equal 0. So we write x plus 4 equals 0. X must be minus 4. There. So these are your two solutions, and you can check them. So if you want to check these are correct, we put them back into your question here or into here, up to you. Doesn't matter which one. So if you put 0 in this first equation, what do you get? 0 squared plus 4 times 0, which is 0, correct, because this equals 0, or minus 4. So let's put minus 4 in there. Let's do it down here. So minus 4 squared plus 4 times minus 4. Does that equal 0? Well, minus 4 squared is 16. 4 times minus 4 is minus 16 equals 0. That's correct. 16 minus 16 is 0. Okay, so let's look at some example down here. So the first kind of question you'll see in my work is questions that are already factorized. You see this here? This is already factorized. So by the null factor law, either this first factor equals 0, so you write that down, 2x plus 3 equals 0 first, or x minus 4 is equal to 0. If those are true, then you'll get a 0 answer here. So if 2x plus 3 equals 0, we just rearrange the equation. Let's do it again. So you can move your 3 to the other side. It will become minus 3, like that. And then if you want the 2 gone, we divide by 2 both sides and cancel. You'll get minus 3 on 2. So that's your first solution. And you can substitute that back here and check your answer. When you put it in here, you'll get 0 for this part. So you'll get a 0 answer. And the same for this one. Let this equal to 0. Just put your 4 on the other side. The minus 4 will become 4. Okay, so that's your other solution here. All right. So why don't you try this one yourself for a minute, and I'll do the answer in a minute. Okay, so I want you to calculate what is x in both of those cases, like that, and the other one here. There should be 2 answers. Can you do that quickly? And then we'll move on. If you don't know, you have to wait for me then. Okay, and then you can copy onto your sheet somewhere. All right, do that one first, and then we'll go on. So that one shouldn't take too long. The good thing, it's already factorized. So split them into 2 parts. So whenever you see 2 factors, write these down separately, okay? So write your first one here and let that equal to 0. So do that first, and then do that for the second factor. So this is your null factor law here, what we're using. So then just calculate x from those 2 equations there. So hopefully you've done that. So in the first question, subtract 5 from both sides. So if you're doing this the long way, we would subtract 5 from both sides, like that. So I'll show you the long way. And so 5 minus 5 is 0. So x will be 0 minus 5, which is minus 5. like that. Okay, that's your first answer. So if you put -5 back into here, you'll get 0 for this, which means you'll get a 0 answer here. It doesn't matter what's in the other factor. So in this one, we could add 4x to both sides. You may have done it differently, as long as you get the same answer. So add 4x to both sides, like that. So 4x minus 4x is 0. So you're going to get 1 equals 4x. You have a 4 here, which you don't want. So we divide by 4 both sides. And then this will cancel. So x is 1/4, like that. So very simple. So when the question's already factorized, you really don't have any problem finding the value, because it's the factorization is actually the hardest bit to do. Okay with that? So let both factor equal to 0 and then calculate. If you had a cubic, here's another example. So 2x minus 1, x plus 3, x minus 4 equals 0. We would do exactly the same thing. This is a cubic equation. It's already factorized here. So if you want to find x here, we would let each part equal to 0. So 2x minus 1 equals 0, x plus 3 equals 0, x minus 4 equals 0. Okay, so then we will just rearrange each one. So x here will be, so if you do this in your head, we'd move the 1 and then we'd divide by 2. So you'll have 1 divided by 2, like that, 1/2. X here, move the 3, will become -3. And add 4. So x will be equal to 4, like that. So they would be the solutions for that cubic equation here. And of course, in this case, you got 3. Cubics don't always have 3 solutions like this, but many of them do. All right. So that idea can be applied to any equation if it's already factorized. Okay, this one, factorizing binomials. Bi meaning having 2 terms here, like this. Bi meaning 2. Like bicycle has 2 wheels, so bi meaning 2. So in this case, we mentioned this earlier, we factorize first. In this case, 3x is the common factor. So we take it out. We would be left with, and that's going to be wrong, isn't it? That should be 2. I just noticed it then. So we can fix this one then. We're going to have to fix this one here. So you can rub that out. We'll fix it. So 3x, either 3x equals 0 or 2x minus 1 equals 0. Why didn't I see that before? Anyway, so we then just find x. So if 3x equals 0, in this case, x must be 0 from this one here. So let's do that. 3x equals 0. If you want to find x, just divide by 3 both sides. Cancel, x is 0. That's this one here. 0 and 3 is 0. So in this one, 2x minus 1 equals 0. 2x equals 1. X equals 1/2. Like that. Okay, so I missed a 2 in here. You can put a 2 in there, and this would be your factor equals 0, and then we solve it. Okay, so you try this one the same way. Can you do this one? And then I'll talk about the next section about patterns you already know how to use, actually. Okay, so do this one here for a minute. So I give you a minute, just do that. You can write it on paper if you don't have a tablet. So I'm going to talk a little bit today, but I think the next period you'll be doing more work. Because I think this is stuff you've done already, so I'll go fairly quickly. Right, so in this question, let's write it again here. So 2x squared plus 18x equals 0. So two terms, so we call it a binomial. The common factor here would be 2x like that. So in the bracket, we would have x, because 2x times x is 2x squared. 2x times what is 18x? That must be 9 equals 0. Got it? So 9 times 2x, 18x. X times 2x is 2x squared. So you've factorized here, factored. Americans would say factored, but I would normally say factorized, but it's the same thing. And they use Z if you're American here for factorize. Okay, so in this case, we let both of the factors equal to 0. So we would have 2x equals 0. So in this case, x must be 0. 2 times any number to be 0, x would have to be 0. Okay, 2 times 0 is 0. It can only be that. This one, x plus 9 must equal 0 to get a 0 here. So x would have to be minus 9. So if you put minus 9 in here, you'll get 0. If you put 0 in here, in your equation, you'll get 0 again. So 0 and minus 9 would be your solutions to that equation. Okay, so that's how you factorize binomials. So just factorize and then find x. So for this section, section 3 is related to the patterns that you know already. So the first one, the difference of two squares. Remember, that's a squared minus b squared, which is a plus b, a minus b. You can swap those around, of course. An example here, x squared minus 9, and we'll do examples for these soon. The perfect square trinomial, tri meaning 3, so 3 terms. So when it's in these two forms, we can write them as perfect squares here. Okay, so a squared plus 2ab plus b squared, a squared minus 2ab plus b squared. So we can write them in this form, and these are two examples here. So let's look at some of these, how to use them. So you need to have them in this special pattern here. So in this question, I kind of skipped a step there, so we might put that step in. I'll write it here and I'll rub it out. So you've got 4x squared minus 25 equals 0. Now there are two ways to solve this, but let's do it by factorizing first, this way here. So what we do, as we did with polynomials, we try to make these power 2. So you're going to have 2x all squared minus 5 squared equals 0. And then we use our perfect difference of square rule to factorize. So you get 2x minus 5 here, 2x plus 5. So just like last chapter. Okay. And then we let both of those equal to 0 here. So we got that. So put your 5 over, divide by 2. You get 5 on 2 here. In this one, put the 5 over, you'll get minus 5. And then divide by 2 again here. So you get minus 5 on 2. All right, this is by factorizing method, but you can find x another way. I'll show you how to do that. So if I just want you to solve that, if I just said solve, I wouldn't really care what method you're going to use. So what you could do, you can move the 25 over. Okay, and then we divide by 4, like that. So then I'll get x squared is 25 on 4. Now, you've got a number squared that gives that. So what I'll do, I will square root both sides, like this. You'll use this method a bit later. So x would equal, now your square root will cancel a square. So we'll get x and root 25 on root 4. I can split that, okay? This can be split to numerator and denominator. And you'll get 5 on 4. But this actually has 2 answers because of the way you take the square root. So that you actually get the same as this here, don't you? So this is plus or minus 5 on 2 here, which is the same as this here. Oh, root 2. 5 on 2 there. So don't worry about this method now. We'll go over this again later. So the main thing is that we can do this factorizing method here. So what you can do, you try this one here. Can you try that one? I'll give you a couple of minutes. Just do that one there. I'm not following the book exactly now because the book assumes you can do all of this already. And I don't think some of you know how to do all the methods. So that's why I rewrote a lot of this section. Okay, so you do this method for this question here. Okay, but remember, you need to make these of powers 2 first. Right, you do that first, and I'll do it in a couple of minutes. Okay. Okay, so for this question, if you're waiting for me, okay, 16x squared, we would make that 4x all squared, wouldn't we? 4x all squared minus 9, which is 3 squared. The first thing you could have looked for is common factors between 16 and 9, but there's no common factor here. So we will write this line first. So a squared minus b squared is a minus b, a plus b, using our rule for difference of squares. So that means this factor, 4x minus 3, will equal 0. And this one, 4x plus 3 equals 0. So x here would be 3 on 4. Move the 3, divide by 4. And this one would be minus 3 on 4. Normally they're the same number, but different sign. So you could write that as x equals plus or minus 3 on 4, like that. That's one way to write it. Okay, so whenever you see something squared minus something squared, then it looks like we can use this method. Generally, we can use it. Even if it's a number that's not a perfect square, you can still do it. So for example, let's just do another one quickly. If this was 4x squared minus 7, you can still do it, but that 7 has to become, let's write this one out, 2x squared minus root 7 squared. So you can do it, but that 7 has to become a root 7 squared, which is 7. Okay, so just be aware of that when they're not perfect square, because 7's not a perfect square. So that's another example there. So for your perfect square trinomials, come up a bit. So let's write that out again. All the writing's here, so you don't have to copy it again, but I'll explain here. So you've got 9y squared plus 24y plus 16 equals 0. So when you see a question like this, and we have something that's something squared on the first term and the last term, so write that as 3y squared And remember the 16, we made that 4 squared. And then in the middle, we have plus 2, which is from our formula, to a b plus b squared. So that basically follows our formula. So a squared plus 2ab plus b squared. If it's in this formula, that is a plus b all squared, like that. And then we just check this middle term here. So we've got 2 3s are 6, 6 4s are 24. So this is all okay, which means that we can write that as 3y plus 4 all squared. This is the same thing. So this here and this here are equal. Let's put a 0 on there. So when you get down to that term, down to here, there's only going to be one answer. So you don't have to do this twice, because what you've got is 3y plus 4. 3y plus 4 equals 0, don't you? That's the same as that. If you solve them, you're going to get y equals minus 4 on 3. And this one gives exactly the same answer. So we don't have to do it twice. Okay, so just pull that one, just do one of the factors, because there's actually only one answer. There are actually two answers, but they're the same. So we only write it once. Good enough. Okay. So you try this one here the same way as what I've shown here and see if you can do it or not. And I'll do that in a couple of minutes. It's kind of a lot, isn't it? But it's things we've basically covered already in polynomials. So what you want, get it in the form a squared. Now this is minus, so minus 2ab plus b squared. So we're using this formula here, which is a minus b all squared. Right, do that one for a minute. So in this question here, let's take a look. So you've got 49x squared, and we know 49x squared is 7x all squared. So change that to power 2 with a bracket. Now our formula says minus 2ab. So we go minus 2, a is 7x, b is actually going to be 1, plus b squared. Okay, does that make sense? So a squared, 7x squared, minus 2ab. So let's put them in different colors. So that's a, which is here, and then b in yellow here. And then you're going to have a and b here. So if everything looks all right, I think it is. So this is 14, 2 7s are 14, times 1 is 14. So the middle term is okay. And the first and last term are okay. So you can write that as 7x minus 1 squared equals 0. So this is your a minus b squared here, what I just wrote then. So that means that 7x minus 1 equals 0. 7x will be equal to 1. And x will be equal to 1 on 7 as your solution. There's only one solution. I'm not going to write out both because it will be the same number, the same as what we got over here. Okay. So let me write, we got 8 minutes, 9 minutes. So maybe I'll stop there with this section. I'll give you a couple more questions to do because the next section is going to take some explaining and more examples. So let's do a couple here. So you've got, let's see, I'll make up some question here. You can try. So 16x squared minus 4 equals 0. Okay, solve this by factorizing. And let's do another one like that. So 25y squared minus 81 equals 0. Okay, so do these for a minute. I don't want to go to the next section because I need more time to explain that actually. So we'll stop here and just do a couple of examples here. Okay, can you do those for a minute? So if you've done those, there's a couple more from the perfect square. So you've got 4x squared minus 4x plus 1 equals 0. And you've got 9x squared plus 12x plus 4 equals 0. So try those using those methods up there. But in the first one, so you should have this as something squared. So that would be 4x squared minus 2 squared. Okay, so the difference of squares here. You could have actually factorized first. So what I'll do, let's factorize that first. I didn't see that. You've got 16 and 4. Well, 4 is a common factor, isn't it? So this would be 4x squared minus 1 equals 0. And then we use the rule here. So you'll have 2x squared minus 1 squared. So you're going to get 2x minus 1, 2x plus 1. So I'll write that up here. So just, and there's a 4 in front too here, equals 0. So you can see here, x will be plus or minus a half for the answer. So for this question here, you should get plus or minus a half for this one. So the same idea for question 2. You're going to have 5y all squared minus 81, which is 9 squared. So you get 5y minus 9, 5y plus 9 equals 0. So y will be plus or minus 9 on 5. You should have gotten that. Okay, you have more space to write than me, so I'll try to make it a bit smaller. So that's the answer for this one here. Okay, got that? Okay, so that's those two. I'll just come up to here. So these two here, we'll do them quickly because we run out of time. So 4x squared. So think about the rule. So 4x squared, this would have to become 2x all squared. Using the rule, we have a minus 2. Then we have 2x in here. Then we have 1. Then we have 1 squared equals 0. So a squared minus 2ab plus b squared is a minus b all squared, like that. So in this case, x would be equal to a half there. So this one here, you can copy these down later if I'm a bit fast. So go back and review the video if you're having any problems with this, and then you can slow it down a bit if I'm a bit fast. So then x is a half here. in the last one, 9x squared, 12x4. So the 9x squared would become 3x all squared plus 2ab plus b squared. I know b because I'm getting it from this term here, which goes there. Okay, so this middle term is okay. 2 3s are 6, 2 6s are 12. So this would become 3x plus 2 as a complete square equals 0. So that means that 3x plus 2 equals 0. So x would be minus 2 on 3. So just one answer there. So these perfect squares, these perfect square trinomials only have one answer, okay? And that's that one there. So I'll leave it there a minute if you want to copy that. The next section, we're going to do the next period tomorrow because I want to spend more time on this section here because they require more examples than what I've put here. I need to make up some more examples for the next section. So that covers the basic ideas. Now this method doesn't work for every question. We need to use this next method down here because sometimes we can't write it as a perfect square, can we?